For this segment, we're going to be going over junctional rhythms. This is in chapter 5 of the ECG Made Easy book, and we're going over the practice strips in the back of the book. I will not be going over the non-junctional rhythms just to conserve time, but there are some great practice atrial and sinus mechanism strips in the back of this chapter. So we know that junctional rhythms originate from the AV node, so our intrinsic rate is between 40 and 60 beats per minute. Things that make this a junctional rhythm is our P waves. Either we will have no P wave at all, or an inverted P wave like you see here, as opposed to a positive P wave that we're used to seeing, or the P wave will come after the QRS complex, and we'll see in all three examples of this in these practice strips. So first we're going to look at figure 5.11, or number 26. And the first thing we want to do, like we do with any rhythm, is we want to see if it's regular or irregular. So you can see here gets a little irregular. Here is a little irregular, so the rate's kind of all over the place, so I just put irregular there. For our rate, we're just going to use the 6-second technique in this chapter since we've already practiced with the small box technique. So I have 1, 2, 3, 4, 5, 6. I didn't really count this guy because he's really cut off, so I just put a rate of 60 beats per minute. For P waves, I put some, and I do have P waves for every QRS complex, but as you can see here, and even this little complex over here, these P waves are inverted. Here's my normal P waves before their QRS complex. But you can see with this P wave that sorry, not that one, that one's up like it's supposed to be. You can see with this P wave that it is actually inverted. And over here we also have another inverted P wave, and over here. So instead of having that normal hill-like structure, we have that dip below the isoelectric line. What I also notice with these inverted P wave complexes is they seem to come early, so they look like they're premature. So I just put some there, but for the, there are P waves for every QRS complex, just some are inverted and some are upright. My PR interval I measured out, it's within normal range of 0.12, and of course I looked right here at a nice sinus complex. My QRS duration is nice and narrow, so that's normal. And then my ST segment is also normal. So you can see here's my J point where the QRS complex ends, and that's right on that isoelectric line. So looking at these complexes, and this one's kind of cut off, so we don't necessarily have to count this one, but they seem to be premature, so they come early. So that would be a premature junctional complex. So why this happens is the SA node's ticking along like it normally should, and then all of a sudden the AV node, for whatever reason, just gets a little excited. It thinks the SA node's not doing its work, and it just fires off a complex prematurely. So for my interpretation, I put sinus rhythm because my underlying rhythm is sinus. You can see my sinus complex is here, and then I have two sinus complexes here. At 60 beats per minute, I put 70 down here because I did count that one in it, with 2 PJCs, and those are the two that I can see that are coming premature. Going down to number 27, or figure 5.12, we're going to start off the same way, regular or irregular. Even though not all my QRS complex look exactly the same voltage, meaning just they're different sizes, they all have the same pattern, and they do march out very regularly. So I put regular for my rhythm. My rate, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10 gives me 100 beats per minute. And my P waves here are upside down, so I'll highlight those so you can see I have that down dip instead of an upwards reflected P wave for every QRS complex. Now there is one P wave for each QRS complex, so I do have a 1-to-1 ratio, and they all do look the same. They're just all upside down, which makes me believe that it's a junctional rhythm. Because my P waves are upside down, I'm not going to count the PR interval, and my QRS complex is only 3 blocks, so that falls within normal range. And then my ST segment, I definitely have some elevation. So this is my J point. This is where the QRS complex ends. So I have QRS. And you can see that it's way above that isoelectric line. So if I match up where my isoelectric line is, so where my P waves begin and end, you can see that I have a good 2 to 3 blocks of elevation here. So just make sure you note that ST elevation in this rhythm. So this rhythm would be considered accelerated junctional rhythm at 100 beats per minute with ST elevation. Remember that to be tachycardic, we would like to see the rhythm over 100. So anything over 60 to 100 would be considered accelerated. Reason being, it's accelerated rate for the AV node, since the AV node intrinsic rate is only 40 to 60, but it's not quite tachycardic because it's not over 100 beats per minute. All right, on this next page, we'll only be looking at the last 2 rhythms here, so I'm going to scoot this up a little bit. So I'm looking at number 29, or figure 5.14. Oh, I'm sorry, this is an atrial rhythm. I think I marked it because it was just a really good example of an atrial flutter. So this is not a junctional rhythm, and you can see these really defined flutter waves. And it's a variable conduction ratio because it's irregular. We have 1, 2, 3, 4, 5 here, and only 3 here. So it does change. So we don't have a regular conduction ratio. So this is, just to review an atrial rhythm, it's controlled atrial flutter at 80 beats per minute with a variable conduction ratio. And I know it's an atrial mechanism, but there weren't too many examples of a flutter in the last chapter, so I did mark that one just to go over it briefly. Now going down here to number 30, or figure 5.15. I'm looking at this rhythm here. It is very regular. My rate, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times 10 gives me a rate of 140. And I don't have any P waves here. So you can see my T wave, and then it goes right into the QRS complex. So I can't measure a PR interval. My QRS duration I measured down here, so where it begins to where the complex ends. It's about 2 blocks, maybe 2.5, so I put 0.08 there, seconds for that one. And my ST segment's normal, so my QRS ends right here, there's my J point, and it's right on that isoelectric line. So since this rate is over 100 beats per minute, we call it a junctional tachycardia rhythm at 140 beats per minute. All right, looking at this first rhythm up here, regular or irregular? Definitely irregular just because this beat right here. Everything else looks regular. So the underlying rhythm is very regular. I have a P wave for every QRS complex. They march out normally, so my underlying rhythm is probably going to be a sinus rhythm. I'm going to go ahead and count my rate. 1, 2, 3, 4, 5, 6, 7. 7 times 10 gives me 70 beats per minute for my rate. My P waves, I do have a P wave for every QRS complex except this one. So not only does this complex come early, because you can see it, we have our regular rate, and then boom, this one comes early. There's kind of a pause, and then we go right back into our regular rate. But it doesn't have a P wave present either. So I can already tell that this complex is junctional. May even have a little bit of a P wave after the complex here. There's a little notch there that may be due to a P wave coming after the complex. My PR interval I measured here on a sinus beat, and I got 0.12 seconds. My QRS duration I measured right here, so the beginning of that QRS to the end of that QRS was 2 blocks. And my ST segment was normal, so again, you want to look at a sinus beat, so I'll look at this one over here. So I have my QRS complex end here, and you can see it's right on the isoelectric line. So my underlying rhythm here, I do have a sinus rhythm at 70 beats per minute with a PJC, and that is this complex right here. There's no P wave before the QRS complex, possibly a P wave occurring after that QRS complex, which is going to make it junctional. right, moving down to number 33, or figure 5.18. Regular, irregular. My rhythm looks very regular. My rate, I have 1, 2, 3, 4, 5, 6, 7, 8. Times 10 gives me that 80 beats per minute. And my P waves here are inverted. So you can see here, it dips below that isoelectric line and then goes into that QRS complex. So here are my P waves. I'll highlight them so you can see them easily. And I just have that nice inversion below the isoelectric line. And that means it's going to be junctional in nature, as all these rhythms are. I'm not going to count a PR interval since they're inverted. You can count a PR interval, but we're just not going to for practice. We've counted PR intervals in our last 4 chapters. My QRS complex is narrow. And my ST segment is normal. I actually have 1 block below the isoelectric line. But remember, with 1 block, we're not going to be very concerned with that. So the name of this rhythm will be accelerated junctional rhythm at 80 beats per minute. Accelerated because it's over that 60, which is 40 to 60 is normal for the junctional, so it is accelerated for that pacemaker site, but it's not quite tachycardic because it's not over 100. All right, on the next page, we're going to be looking at number 36, figure 5.21. This rhythm, we can tell right off the bat it's slow, so we know it's going to be, slower than normal. And I do 1, 2, 3, 4, 5, so 5 times 10 gave me that rate of 50 beats per minute. And we do have some P waves here, so I have a P wave here, here, and here, but not here or here. So half of my rhythm is junctional, half of it is sinus, because I do have a P wave for every QRS complex. I have T waves here, although my T waves appear to be inverted. No ST elevation or anything going on. So this is actually sinus bradycardia that turns into a junctional escape rhythm. It's not junctional bradycardia because it is within that normal range for the AV node. So it's just a junctional escape because it's between that 40 to 60. All right, on the next page, I'm looking at number 37, figure 5.22. And I'm trying to look and see, I want to see if it's regular. So my underlying rhythm here, it starts off very, very regular, but then starts to get slowed down here. So I put underlying regular, but it is irregular, so you can put irregular for that interpretation. For my rate, I'm just going to use the 6-second technique. So 1, 2, 3, 4, 5, 6, 7. Times 10 gives me 70 beats per minute. For P waves, most of my complexes do have P waves. So you can see here, this complex, however, does not have a P wave. When I do have P waves, I measured my PR interval, so I measured on my sinus beats, and I got 4 small blocks, which was 0.16 seconds. My QRS duration was only 1 block. You can see it very well here where the QRS starts and where it stops is 1 block, maybe 1.5. So it's well within normal limits. It's narrow. And my ST segment is normal. So my QRS complex, that's here. And that's right on the isoelectric line. So this beat is obviously junctional. It has no P wave. But it's not a premature junctional beat because it doesn't come early. It doesn't come over here. So we call this a junctional escape beat. So it's a sinus rhythm at 70 beats per minute with a junctional escape beat. And what's happening here is that my SA node's firing off at 70 beats per minute, and then all of a sudden it just decides to take a break for whatever reason. My SA node just stops firing off. So once that happens, we have a fallback mechanism where it falls back to the next node, which would be my AV node. So that AV node begins to kick on, so we keep a heart rate going. and we call that a junctional escape beat. And usually that'll trigger the SA node to start firing again. So usually we only see one. We could see the patient transfer into a junctional rhythm, but usually we only see 1 or 2 beats, and then the SA, the sinus mechanisms begin picking up again. All right, number 38, figure 5.23. It is regular. So I put regular, my rate, 1, 2, 3, 4, 5 times 10 gave me 50 beats per minute. And you can see here I have no P waves. It's a straight line right into that QRS complex, so none, and there's no PR interval. My QRS duration, it's a little difficult to measure because of the ST elevation going on, but I marked it here, and I'll mark one off here, so right where my QRS begins to right where the QRS complex ends. It gives me exactly 3 blocks, which is where I got the 0.12. Remember, each small block is 0.04 seconds, so I just multiplied that by 3 to get 0.12 seconds. And I definitely have some ST segment elevation here. If you are having trouble seeing that, just take your scrap paper, line it up to where the QRS complexes begin, since we don't have P waves and we can't use that as a measurement. That's my isoelectric line. And you can see definitely here we have 3 boxes of elevation right where the QRS complex ends, where our J point is, never goes back down to that isoelectric line, and that's indicative of a heart attack. So we definitely want to make sure we note that elevation. So this rhythm is a junctional escape rhythm at 50 beats per minute with ST segment elevation. And the reason it's junctional escape is it falls within that normal intrinsic rate of the AV node of 40 to 60 beats per minute. All right, we're going to be skipping ahead a little bit. And I'm looking at number 43, which is figure 5.28. And we skipped 1 page. So I'm looking at this rhythm right here, and you can see I already marked some things out here, so I'll show you what I marked off. First of all, we want to look at just the rhythm. Is it regular or irregular? And we can see here that this one is very regular. My rate, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14 times 10 is 140 beats per minute. And we have no P waves here, so that's what I was highlighting over here. We have that straight line along the isoelectric line right into our QRS complex. It's a little kind of difficult to see because you have this huge ST depression. And what I circled here is in the ST depression is you kind of see those P waves that are happening after the QRS complex, almost like we saw in that A flutter rhythm that we looked at in the chapter before. But you can see that P wave buried down in that QRS complex, so it could be that the P wave is just happening after the QRS complex, which makes it junctional. So no for the P waves, we can't measure a PR interval. My QRS duration is nice and narrow and within normal limits. And then like I said, we have that ST segment depression. So what I had marked here was that isoelectric line. And I just put my piece of paper where the QRS complexes begin to get that line. And we have, 4 boxes where my J point is, where my QRS complex ends. 4 boxes below that isoelectric line. So there's definitely some ST segment depression. So the name for this rhythm is junctional tachycardia with ST segment depression. Remember that C with a line means with. And it's tachycardia because it's over that 140 beats per minute, coming from the AV node, from the AV junction, because we have absence of P waves, possibly even that P wave coming after the QRS complex. Looking down at number 44, or figure 5.29, regular or irregular. This rate seems very irregular. My rate is 100, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 gives me 100 beats per minute. I have no P waves. This is definitely a straight line that goes right into that QRS complex. my QRS complexes are only one block, maybe to a block and a half. So it's 0.04, very narrow, falls within normal limits. For my ST segment, it is normal. So here's my J point where my QRS complex ends. So it does end on that isoelectric line. This dip below that you're seeing here is actually inverted T waves. So that's why the T waves are dipping below the isoelectric line. They are inverted. So for my interpretation, I put accelerated junctional because it is not over 100 beats per minute. We don't consider it junctional tachycardia. So I have accelerated junctional rhythm with inverted T waves. Oh, and I forgot to put my rate in there at 100 beats per minute. All right, moving down to number 45, figure 5.30. We can see right away that it's a little irregular. So I just put an IR here for irregular. For my rate, I have 1, 2, 3, 4, 5, 6, 7, 8 times 10 gives me that 80 beats per minute. And now let's look at our P waves. So I have a P wave here that's normal, upright, P wave here, normal, upright, and then here, this beat that seems to come early, I have that inverted P wave that dips below the isoelectric line. So that's why I highlighted that one. Then I have a little space. I have a P wave that's normal and upright, and then an early complex again where it has that inverted P wave right here that's been highlighted, and then normal, normal. So I just put most. There is a P wave for every QRS complex. Most are upright, most are normal, but these premature beats have that inverted P wave, making me believe that those are junctional, premature junctional beats. I measured my PR interval here on a sinus beat. It was within normal limits. My QRSs are nice and narrow within normal limits, and my ST segment is normal, so I always look at a sinus beat when I'm looking at these things, but you can see QRS ends right here, right on that isoelectric line, and then goes up into the T wave. So for this interpretation, it's a sinus rhythm at 80 beats per minute because my underlying rhythm is sinus with two PJCs. I have a PJC here and a PJC here, premature junctional contraction. All right, we're looking at number 46 now. Figure 5.31. Regular or irregular? It is regular. My rate, I have 90. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 gives me 90 beats per minute. P waves, I'm looking from here to here. So I do have some P waves over here, but for the majority of the rhythm, I have no P waves. So I want to look at that, and it's just a straight line right into that QRS complex. So I put none there. And then for my PR interval, obviously we cannot count that without having P waves present. My QRS complexes are nice and narrow, only measuring one block, and my ST segment is normal. Maybe half a block to 1 block below, but unless it's 2 blocks, we don't really measure that. So for my interpretation, I did put a sinus rhythm converting into an accelerated junctional because I do have those regular sinus beats here, and then goes into a accelerated junctional and then back into a sinus. So sinus rhythm into accelerated junctional at 90 beats per minute. And it's accelerated because it's not quite tachycardic, but it's over that normal intrinsic rate of the AV node. All right, last page here. I'm looking at the last rhythm here, number 50, figure 5.35. It is regular. My rate, 1, 2, 3, 4, 5, 6. 6 times 10 gives me that 60 beats per minute. My P waves, I definitely have no P waves here. You can see it's just a straight line into that QRS complex. So I cannot count a PR interval. My QRSs are nice and narrow. In my ST segment, I do have some slight depression. And I'll kind of highlight that here. So I'm just going to line my paper up to where those QRS complexes begin. Make a nice nice thick lines so you can see it. So I do have one block of depression, but it's definitely not enough to be concerned about, so we're not going to put it in our interpretation. So for my interpretation, I have a junctional escape rhythm at 60 beats per minute. Junctional escape because it's between that 40 to 60, that normal intrinsic rate of that AV node. So for whatever reason, our pacemaker has escaped to the AV junction, giving us that junctional escape rhythm.